All right, so for oxidation state of sulfur, this is +4 and +6. Anyone, any issue, please sound up. If not, this one should be quite easy to calculate. Okay, then for 4B, I'll give you the two template. One of them, you can go for oxidation state. So because they go from +4 here to +6, so he's oxidized. So I'll say sulfur dioxide. This is again standard answer. So the whole sulfur dioxide oxidized because the oxidation state of the element sulfur, you will say increases from +4 in SO2 to +6 in SO3. Okay, this can be one of the answer, but the other one we can go for is strictly gain of oxygen. So we can also go for SO2 has been oxidized. Okay, gains oxygen to form SO3. These two are standard answers. Okay, that's for sulfur dioxide. This is a QA question. So we want to describe a test to see whether a reducing agent's present. So we can test the reducing agents with the standard equipment is acidified potassium manganate. Okay, the formula is KMnO4. Okay, observation is if reducing agent present, the purple KMnO4 turns colorless. Okay, this is one of the oxidizing agent that you can use to test. Alternatively, you can also use potassium dichromate. So if the reducing agent is present, this potassium dichromate, which is K2Cr2O7, okay, that if you use dichromate, then the options will be orange, potassium dichromate turns green. Okay, both are acceptable. Okay, that's all for question number 4. Okay, so do not fool by the descending or ascending order of reactivity. So this one starts most reactive, we will say descending order of reactivity. If they want you to go with the least reactive first, then it will be from the least to the most ascending order of reactivity. Okay, so just put a note there. This is also known as descending rate reactivity. Okay, my answer is this. Anyone needs me to explain? If not, I'll take it that you understand how this thing works. Then I will move on. 30 seconds if you need, sound up. Okay, let's look at B1. Okay, it says hot water and steam not carried out because you see that with cold water, it is already very vigorous already. So it's something that is so reactive with cold water. If you put into steam or you put into hot water, the reaction is going to be even more vigorous. So it's not just vigorous, it's possibly dangerous to conduct that reaction. So we do not want to do it for safety reason. Okay, so for this case, I'll just mention that since T, I'll use exactly the word it says over there, reacts very vigorously. Okay, then I use the word may because I do not know what, how dangerous it is. It may react explosively with steam and hot water. Then we will say because of this, it is dangerous to carry out the experiment. Okay, that's all. Okay, B part 2. The question says X is a product between metal T and cold water, and X can dissolve in water to form pH 14. So pH 14, we know that this thing here is a strong alkali. And because it's a strong alkali, it is likely to be a group 1 element. And we also know that group 1, they do react with water. You remember reactivity series, potassium, sodium. Okay, then we have calcium. Together with calcium, these are the top 3 in the reactivity series that will react with water, and they form metal hydroxide and hydrogen gas. So we can go for, let's say, potassium, and the substance form will be potassium hydroxide. Of course, you can switch this out for sodium. You can switch this out for lithium, also can. Group 1 metals. Okay, so this one will change according to what you have. All right. Okay, I just screw up a bit for you. Okay, you don't react cold water. Don't react with hot water, but it reacts with steam. Okay, you react with steam. That means if you remember, those that react with steam is the one which is your magnesium, zinc, and iron. These 3 are the ones that react with steam. So as we know, lead don't have hydrogen, and then copper and all the way down. Okay, because it is above hydrogen in the reactivity series, it will react acid. So this reaction is going to work. So my answer for this is that it's going to be able to react with an acid. So we will say we will say that metal U. I won't say vigorous reaction because it's not that reactive already. But then again, it could be magnesium. Magnesium, it will be very vigorous. So what should we do? Okay, this one will be very fast with acid. This metal will be slower. So I'll just use somewhere in between, right? Metal with U, okay, we'll say likely to react. Because the question says how, I'll use the word readily to indicate that not very fast, also not very slow with HCl. Okay, number 5, please jot this down. Any questions? So we should remember carbon monoxide as the gas that's formed from incomplete combustion. Okay, no need to mention over here. The question only asks us the effects. So this carbon monoxide we know is from incomplete combustion of fossil fuel. Okay, so in this case, we'll say that carbon monoxide will actually form, say, stable compound with hemoglobin in the blood. So the effects of this is that it reduces the blood's effectiveness to transport oxygen. So this may lead to things like dizziness, short of breath, suffocation that can lead to death. Sulfur dioxide here is an acidic oxide. So I will mention that dissolves in rain cloud to form acid rain. And what's the effects of acid rain? There are a few. Number one, you can see it makes the soil and water bodies in soil too acidic for the plants to grow. And also as an acid, they were able to react with the metal structures of buildings. And also as a metal, because concrete is made of cement. Cement is basically carbonate. So metal pretty straightforward. This one basically is because it contains cement. And this cement here is basically contain calcium carbonate. That's why they will corrode the cement and the metal parts of buildings and structures. Okay, any questions for number 6? Any further explanation beyond it? Okay, volatile. Volatile misconception is reactive. It's not volatile, simply means that it boils off easily. Okay, so in the first place, you see the description here is a volatile liquid. That means it must be a liquid at room temperature in the first place. So from here, you can see that room temperature is 25 degrees Celsius. So this is room temperature. We have these three here, they are liquids. So volatile means that they got to boil off easily. So in order to boil off easily, the boiling point must be pretty close to the room temperature. So we have R, and the reason is because the BP is very close, or it's the closest to room temperature. Okay, Q is likely to be pure water. Answer is no, because you need to mention the melting point of Q is negative 114 degrees C, while for water, the melting point is 0 degrees Celsius. So simply based on the melting point will do. Okay, 10 seconds. Any questions for this? Or jot it down. Then we move on to question 8. Okay, this is my answer. If you are okay, then no question. Otherwise, please check with me if you don't know why. Mixture, compound, compound, elements. Okay, whichever parts you on guess correctly or wrong, let me know. Like now, then I explain. C is a compound because it says it's a substance. So C, if you heat it, it turns into a silvery liquid, likely to be a metal plus oxygen gas. That means C is likely to be a metal oxide. Metal oxide is a compound. Make sense? Mm. Just a point on B. It says it's a liquid that gives you CO2, CO2 and water only. So most likely it is an alkane or an alkene. Okay, with something like CH something. So when you burn it, you get CO2, you get H2O. Okay, something like this. All right, if no question. Oh, by the way, D, yellow solid. In syllabus, not many yellow elements. This thing is actually sulfur. Sulfur plus oxygen, SO2. Yellow solid is actually the sulfur element. Okay, number 9. This is my answer. If you don't know why, again, let me know. Endo, exo, exo. Okay, whichever part's not sure, please let me know. Number 3 is exothermic because this is a combustion process. Combustion process means something plus oxygen gives you something here. When something plus oxygen, this is combustion. Combustion is always exothermic. Okay, that's all. Right. If no question. Anyway, number 4, you all should recognize it as neutralization. Neutralization is exothermic also. All right. If no questions for this rate of reaction, can I get you all to try out the next part, including the moles, especially the moles. So you all help me do a quick sketch. Don't need to be accurate, just point by point and then get a rough shape will do. And then settle the moves. Okay, we'll go through in a few minutes. Again, when you all are done, let me know. So 5 to 6. Somewhere here is a horizontal line. Okay, so let's say something like that. I think it's something like that. Okay, so from your graph time taken for half the acid to use up. Okay, half the acid to use up is not half the time. Half the acid to use up is when you locate 50 cm cube produced. Because when in this case, you know that excess copper 2 carbonate, okay? That means all the acid is used up. So all the acid used up means that if the total volume is 100, when half the acid is used, that means it's 50 cm cube. So the correct way is to go to 50, and you get about roughly about 0.6 minutes thereabout. Okay, I don't have a good graph. Your graph should give you about 0.6, 0.7, I think. So let's say mine is 0.6 minutes, okay? So you can see that the whole reaction, right, takes 5 minutes to complete. Okay, but the first half of the reaction takes only 0.6 minutes. Then the second half of the reaction takes additional 4.4 minutes for the reaction to complete by 5. Okay, this is a very, very clear-cut concept to tell you that reaction is always fastest at the beginning, because at the beginning, the concentration of the acid is the highest. Oh, sorry, this one is a 1 point something. Okay, maybe my gradient not steep enough. Okay, let me do a better one. Let me do a better one. Okay. Otherwise it's not accurate. Okay, so we have one at 0, and then 60, 80. Because it looks a bit shady, because 60 already, first minute already 60. So I just feel a bit wrong with it. So about 60, then 80, somewhere here. Okay, so the rough steepness is like this. I see the number, I feel a bit wrong in it. Because by the first minute, he already hit 60. Okay, so it's probably something like that. So I go to 50 cm cube, somewhere here, about 0.7. Yeah. Because I was estimating it for this one, because 0 to 60 only 1 minute. So 50 should be less than 1 minute. I stupidly draw on a curve more than 1. So this one is wrong. So my gradient is not good just now. Okay, so something like this. So you can see that for the first 50 cm cube, you only take 0.7 minutes. And for the second 50 cm cube to reach 100, you take 4.3 minutes. So you can see this shows that reaction is always very fast at the beginning due to the fact that you have higher concentration of acid at the beginning. So as you react, the acid gets lesser. Therefore, the concentration decrease. Then we say that now there are lesser particle per unit volume. So the collision decrease and everything decrease and so forth. Okay. Any question for the reason why the reaction should be slower towards the end? Always due to concentration, right? Yeah, so this curve I think is more accurate. So 0.7 minutes, this one is done. Okay, most of acid that reacted. So first of all, for this case, I will find the moles of copper 2 carbonate. So 4.96 divided by 124. Yeah, that's the calculator first. 0.04. Okay, and then because the copper 2 carbonate is to HNO3, the ratio is 1:2. So 0.04, 0.08. Okay, this is our answer. CO2 moles is 1:1. So Cu carbonate is to CO2 is 1:1. 0.04 is to 0.04. So volume of CO2 will be your 0.04 times 24 dm cube, 0.96 dm cube. Okay, that's all. You all should all have it. Okay, I'll do 11A part 1, part 2 with you all immediately. Then you all help me set up the QA. So all this is used to neutralize the stomach acid. So that means this thing has low pH. So what will be the effect of the pH value on stomach acid? Okay, because you neutralize, neutralize will be less acidic. So in this case, it is likely to increase the pH of the stomach acid. Okay, so in this case, the question wants us to do magnesium hydroxide reacting with the stomach acid. pH value, did they say, stomach acid is hydrochloric acid. Okay, so we just hit Cl. Then we get magnesium chloride plus H2O. Okay, so from here, balance equation, balance the chlorine, balance the OH. Okay, next, the question mentioned about state symbol. So because it's tablet, solid, acid always AQ. Magnesium chloride is soluble, AQ. Water, liquid state. Okay, so that's how we will do this. Okay, if no question, please help me out with 11, B1 and B2. Yeah, I think this is the last one. Yeah, then after that we'll go to Paya Methodist. If how did this here? Done with QA, let me know. You can start to help you, which is those things that's from the QA list. So for sure, QA list is this one, this, and this. This is the positive ion test. This is a gas test. We'll find out what is it. And then these two is like a reaction. White powder A and dilute sulfuric acid, dilute nitric acid is a reaction. Okay. So this thing is a acidity test, but it's not in the QA list. So QA list only the 3 ticks only. So from the 3 ticks, you should be able to get the rest. Okay, when you manage to get it, let me know. Then I give you all my answers. Okay, you don't need to write both the formula and the name because the question says identify. Identify, you can go either one. Okay, but most of the time, right, I will if the question says name, okay, the verb is name, you have to write down the name, you cannot write the formula. But as a habit and safety, I always write the name. Unless the question says write in terms of their chemical formula. Yeah, I will only write chemical formula. Okay, even for those just now beforehand, right, when I do redox, right? You see, when I do redox, I actually use like I wrote things like SO2O, SO3, but I write shouldn't. But if you do not know the name, right? Let's say like in this case, you don't know it's called sulfur dioxide or sulfur trioxide, then don't risk. But if you know writing word or their name, it's actually better. Okay, under what kind of circumstances will I write the formula? Will I write formula, right? Number one is the question says so. Okay, right, in terms of formula. And when I write chemical equation, other than that, most of the time, I try to avoid writing formula. I'll try to write the word. But of course, I will say in front, if you do not know the name of the formula, then write the formula is safer. Or don't mix up the sulfur dioxide or the trioxide naming. So not sure, just write down whatever the question says. Okay, why is it lead, right? Because now after they react the nitric acid, you get three things. Okay, you get CO2 because this is a metal carbonate. Okay, so over here you get your water. Over here you get your salt. Your salt is the metal nitrate. Okay, whatever the nitrate is, could be aluminum. So how do I know it's lead? Okay, sodium hydroxide, white PPT dissolved in excess. White PP dissolved in excess, there are three possible outcomes: aluminium, lead, and zinc. Aqueous ammonia do not dissolve. It's either aluminium or lead. But I think aluminium not in syllabus. So that's why it's lead. The one that is aqueous ammonia, white PPT, soluble in excess. This one is zinc. Zinc is the only one that has a positive ion test and is soluble in both of them. Lead and aluminium, they are not. Lead and aluminum only soluble in sodium hydroxide excess, but not aqueous ammonia excess. That's why I'll choose lead over here, because aluminum don't need to know. Is this all right? Actually, if you write aluminum, not wrong also. If all your lead answer is aluminum, by right, you are correct also. Is it okay? So I think in this case, I will accept both aluminum and lead, because there's really nothing here to suggest that it must be lead and not aluminum. So both goes, I guess. So if you can get that correct, it's good. Okay, next, aqueous ammonia form dissolved in water. Okay, we're slowly added to copper 2. So this is a copper 2 aqueous ammonia test. So you will get a blue PPT form. And then we'll say, in this case, the blue PPT dissolved in this case, excess aqueous ammonia. Okay, this solution here is your AQ ammonia. So dissolve in aqueous ammonia to form a deep blue solution. Okay, this is the test for copper with aqueous ammonia. Okay, please jot down whatever you need. Those who are done, you can proceed to Paya-Lebar Methodist Girls. Okay, for our last paper. The first question is metals. So you can see that in this case, the peak percentage is somewhere around 3 to 4% of copper use mixed with aluminum gives you the maximum toughness. So let's draw this down, okay, about 4%. So anything more, anything less will give you a softer alloy. Okay, so how to draw a well-labeled diagram of beryllium? So copper atoms are a bit bigger. Copper atoms are the ones that are slightly bigger, and they are the ones that disrupt the aluminum. So normally how I would draw this, I'll just draw two bigger ones. Because the question says well labeled, so I need to label this. Okay, then after that draw a sunflower, then draw another sunflower. Okay, so once you have your two sunflowers, draw some more of the smaller ones to join them together. Okay, something like that. Then yeah, then I will have we'll label this. Copper is in lesser quantity, so copper atom. Then the smaller one will have aluminum atom. Because the question wants us to label. So why is this stronger? The next part is the standard answer. Okay, so it has different size compared to aluminum. Normally I won't name the metals, but since it's already here, right, I'll just say that it's different size with the aluminum. And then this will actually disrupt the orderly arrangement. This one is standard. Okay, and then because it disrupts, it makes it more difficult. Okay, and because it's harder to slide, and hence it will be stronger. Okay, I'll leave this here a minute for you all to jot down. Then we'll move to question 2. Okay, let's go to the next part. With the indicator. Okay, so condensation. So condensation is your gas to liquid. So the question one changes in the spacing. So because of a gas, you'll say that the spacing actually decreases. So the particles went from far apart to closely packed in a liquid, right? Then for movements, generally, I will say that the movement actually slows down. And that's because the particles went from, because these changes are, we got to state before and after. Okay, went from moving randomly at high speed okay, went from this to sliding over each other within the liquid. Okay, that's for question 2. Okay, yeah, let me see. Oh, before far apart is the particles. The particles went from far apart to closely packed.